Now I'd like to take these ideas that we've talked about with transforming data and logarithms, and I'd like to see how they work with an actual problem. So I've got a problem here in front of you, and the first step is to go ahead and type the data in. There's several steps to do. I'd like you to do it on your own, so if you need to pause the video so you can do it and then see what I say about it, that's a great way to go. So I've got mine typed into L1, and it says draw a rough scatter plot. So go to my stat plots, turn it on. It's a scatter plot of L1 and L2, and I hit zoom 9. And I can look at this right here, and it looks like there's a curve. And we'd sketch that in right here. And then it says, find the LSRL. Is this a good idea? What are R and R squared? Interpret these, make a prediction of Y when X equals 70. Whew, that's a lot of stuff. Okay, so let's talk about it. Find the LSRL. Okay, that's fine. I'm going to do all of this, and then I'll write it down. Stat calc, and we like to use number 8. And I want to go ahead and store it into the reg EQ, vars, yvars, function, y1. Calculate, check where O, R and R squared aren't there. So I can either go to my catalog, which is my preferred method, or I can go to mode and turn my diagnostics on. Some of you would say, why is catalog the preferred method? Because in the older calculators, it isn't listed in mode, and you have to do it through the catalog. So I've turned it on. Let's go back to stat calc number 8. I no longer need to store it in the regression equation. See, if I press y equals, it's already there. So I don't really need to store it again. You could if you wanted to. Calculate, it'll just replace what's there with the new thing, which is still what's there. And I get this. If you didn't get this, probably want to pause the video, figure out what numbers you have wrong so that we all have the same thing. So here's what I've got. There's R and R squared. Interpret them. Make a prediction of Y when X is 70. So to predict it, really what I want to know is if here's my graph and here's my line, when X is 70, what is Y? And so to do that on my home screen, I can press vars, yvars, function y1 of 70. There it is. There's my prediction. So do all that. Make sure you can do all that, and then restart the video. I've got my answers typed in here. So here's my graph. I've labeled my axes. I have a title. I look at it. Is it a good idea? Well, the good idea part's going to come from the residual plot. So I'll check that in a second. Notice I put my hat on my line. I should define X and Y, but in the problem they didn't give me a context, so I can't do that. What are R and R squared? Interpret these. Well, my R is pretty good. My R squared is pretty good. That means I have a strong positive linear relationship. The R squared is the coefficient of determination, telling me 94% of the change in Y can be explained by the least squared regression line of Y on X. When I plug in 70, I get this, which is what we had a second ago. Uh-oh. So I paused the video for a second to see what the discrepancy was, and when I discovered it, I was kind of disappointed in myself. What I actually did to get this incorrect value that I'm now going to change was I just used this equation right here. Well, this equation, of course, contains round-off error, so I should be doing it the way I did it on the calculator. Let's fix this and turn it into a 0 and make it better. Now, to do the residual plot and answer this next question, I go second stat plot, and this L2, I'm going to change it to list resid. So now when I hit zoom 9, I get that. Now again, this line here is simply this equation. I can turn it off if it bothers me. But here's what I get. I see a clear pattern. Big problem. Don't like it. You can see the pattern on here. Big pattern means what I did wasn't the most appropriate way to go. Of course, I knew that because back at the beginning, I could see, even with my own eyes, the curve right here. Find the residual for the first point. You can hit trace and see the first point at that is 1030.2. That's the residual. You also see in my notes here that I showed what would happen if I plugged in the values and used the equation. I could calculate it the same way. Now the next part says let's transform the data, take the log of x and y. Doesn't really explain why, just trust me, take the log of x and y. So in my calculator here, in L3, I'm going to make it the log of L1. And then L4, I'm going to make it the log of L2. Some people prefer the natural log. I am not one of those persons. You can do it that way if you want. I'm using the base 10 log. And I filled in my chart up here at the top to show what I've done. You might have to pause to catch up and do that. Now let's make a scatter plot of L3 and L4. L3 and L4. Wow, pretty stinking linear right there. I like it. Notice, however, when I graphed it, I had to write log of x and y. And if you wanted to know what values to put on the scale, hitting window can give you a pretty good idea of what those values would be. Find LSRL of the transformed data is a good idea. What are R and R squared? So now what I want to do is go stat calc number 8, L3 and L4. And I'm going to store this one, but I'm going to store it into Y2, just so I have them both in case I need them later. Wow, look at that job. It did a great job. But I know when I write my equation down that I need to stick logs in here like I've done here. Technically, the hat is over all the log y. It's log y hat. It's not the log of y hat. But we're not going to be too concerned with that in stat 1. % of the change from y is explained by the LSRL of y on x. Remember, strong correlation doesn't imply causation. It's looking really good. Let's check the residual plot. Now these are my new residuals because I erased my old residuals when I did regression again. Well, they're kind of scattered. Let's check this out. Press trace. Look at the magnitude of these residuals. Teeny, teeny, tiny. Now, really, these are logs of magnitudes, but they're still really, really, really tiny. 10 to the negative 6th. And it says, what's the sum of the residuals? Of course, it is 0. If it isn't, it's probably due to round-off error. See if it'll let me sum up my resids. Basically 0. It really is 0. The calculator can't handle round-off error out here apparently at the 12th decimal place. Use your regression line to predict if x is 70. So now I've got vars, y vars, function y2 of 70. I think this guess is going to be a lot better. So let's check it out here. If x was 70, something like, wait a minute, it doesn't look good. So what gives? I thought this line did a really good job, but when I plug in 70, I get 140. Oh yeah, because when I plug stuff into this equation, I don't plug in x's, I plug in log of x's. And moreover, when I get answers, I don't get y's, I get logs of y's. So what I want to try is this. y2 of the log of 70. And then when I get this answer, I want to anti-log it. 4,900. 4,900 seems like a much more reasonable answer. If 70's in here, 4900s in here. That looks like a much better idea. And here's how I showed the work when I did it this way. Finally, it says untransform your data to find a regression equation in terms of x and y instead of log of x and log of y. So I'd like to look at this on a notebook. I'll work it through with you. So if I look at my equation was negative 1.7949 times the negative fifth. Oh my. Okay, so let me do it this way so I can have it on my screen better. Stat calc 8. All right, so when my calculator told me that, this value and this value are really logs. So really what I've got is the log of y equals a plus b log of x. And I'm going to take those a's and b's and stick them in here. And then I'm going to take anti-logs and get rid of those logs and try to solve this for y hat. So what I have is the log of y hat equals 179 plus, maybe I'll just call that 2 log of x for the time being. So that's the log of y hat equals that plus the log of x squared, or the log of x to the 2.000011771. So now I want to anti-log both sides. So I'm going to anti-log this side and anti-log this side. So the left now just becomes y hat. There's a little bit of an issue with that hat, but we're not going to be concerned with it right now. The right side is 10 to the 179 times 10 to the log x squared. Now the 10 to the log x, this part here, goes away, and I've just got x to the 2.000011771. And then this other part, 10 to that number. Let's see if I can get my calculator into doing that for me. Remember, that was A on my calculator. So let's go 10 to the VARS statistics EQ A. I could have typed it all in, but this is clever. Oh, look at that. Basically, 1. So basically what I have here is y hat equals 1 times x squared. At least if I round it to 2 or 3 decimal places, that's what I get. Now notice what I've got here is a power function. But I didn't do a power regression model because I don't really understand that at this point. I do understand linear regression. So using a little bit of transformations, I tricked the calculator into doing linear regression on logged data to end up with a power function. I hope this helps. I got another video where I will show you an exponential function and how that would work.